So here we are with our final strategy. We're going to look at final subclass of SearchTaskGangCommon superclass. This is the OneShotExecutorCompletionService subclass. And this particular implementation is going to do a one-shot search for words in a list of strings with maximal concurrency. And you'll see what that means in just a second. You can find the code here. So the executor model is going to be a variable size thread pool. It's actually a work stealing pool, as we'll see. And the unit of concurrency will be task per search word and input string. So it's got more concurrency than what we saw before. And its results processing model uses an asynchronous future model that processes the results immediately as they complete. So this gives it a little bit of an edge over the previous examples we've looked at. In particular, with what we looked at with the synchronous future processing model with the one-shot executor service future strategy we looked at in the previous part of this lesson. So this uses a work stealing thread pool, which is created by the executors factory method. Here you can see executors.new work stealing pool, which makes the appropriate executor. And a work stealing pool uses something called the Java fork join framework, which is super clever and something that you should be familiar with. We'll talk about it later in the course, but basically what it does is it allows you to have threads work collaboratively to keep core utilization as high as possible by stealing work from threads that have too much stuff in their queue when another thread has nothing. So we make a work stealing thread pool, and then we use the executor completion service, which wraps this work stealing pool to make the completion service field, and that will concurrently process the search results just as soon as the futures are done. Each input data element is processed concurrently, as you'll see here. So for each of these things, we're going to go ahead and execute that, and the results processing will start as soon as any future is done. We'll take a longer look at that in a minute. So notice we have one form of concurrency here we're going to call execute on the task. So that means each input string will be running concurrently. And then each input string that's running concurrently will also use the completion service to submit the word to be searched for. And that will also run concurrently. So we've got concurrency in 2 dimensions, which is pretty cool. And notice that the futures that are returned by submit are simply ignored here. We don't care. They're handled through other means. These are the other means. This is the concurrently process queued futures method, which will be processed concurrently with respect to all the submit calls we looked at earlier. And what's going to happen here is we're going to iterate through all the counts of all the current processing we've submitted, and we're going to call take on the completion service. This call may block if nothing is completed yet. But as soon as something completes, then we go ahead and call get on it, and get, which is being called in a future here, will not block since futures are not put into the completion queue of the executor completion service until they've been completed. So let's go take a look at the code for this stuff. And you'll see that it's actually pretty concise because we've pushed some of the stuff that was done in our application code into the executor completion service framework. So here's the one-shot executor completion service class, which is a SearchTaskGangCommon subclass. It has a completion service field that's parameterized by search results. Its constructor calls up to the superclass for SearchTaskGangCommon to initialize the words to find and the strings to search. We'll make the new work stealing thread pool, which uses the Java fork join pool implementation. Then we make an executor completion service that wraps that work stealing pool. Here's initiate task gang. So what's going to happen here is we're going to take each string in our list of strings to search, and we're going to make that into a runnable. We're going to execute that. And those are all going to get started running. And then we're going to call concurrently process queued futures. What will happen here is once we call execute on this runnable, that's going to end up calling process input with this string. And for each word, we're going to go ahead and submit the search for word task, which will go look at this concurrently. Again, this does not actually do anything with the future that's returned from submit. That's handled through the executor completion services completion queue. Speaking of which, here's concurrently process queued futures, which figures out how many items we have to process. And then it iterates through all the items, and it calls the take method on the completion service, which will block if nothing is there. Once we get back a result from take, then we go ahead and call the get method on the future, which will not block since it couldn't have been in the queue if it had not already finished. And so once we get back that result from the future, we go ahead and print the result. So that's the implementation that I wanted to look at for the executor completion service. So that finishes our coverage of the different ways of customizing the executor framework relating to cached thread pools, fixed size thread pools, work stealing pools, and then having the executor create virtual threads for each task.